In this section or video, we're going to take a look at section 3, problem number 3. So for problem 3, we said suppose the Utah economy initially in equilibrium, so supply equaling demand, with the following labor supply and labor demand relations. So labor supply being equal to 150,000 plus 250 W, and labor demand being equal to 1,900,000 minus 220 W, where W is the monthly wage and L is the number of workers. So this is relatively simple to think about. And we've then said there's a surge in high-tech workers or high-tech development motivating workers to enter the state such that labor supply increases by 50,000 workers at any wage level. Well, if that's the case, so we have this in equilibrium. So in equilibrium, there is no unemployment. Labor supply is equal to labor demand. We can easily identify some value, and that's the first thing we do here in A, is we identify the equilibrium wage and labor levels. So we simply set those two equations equal to each other such that 150,000 plus 250 W equals 1,900,000 minus 220 W, which is going to then yield a W star, or the market clearing wage, which we know is a monthly wage of 3,723.4. And then we can also solve for L star by just plugging the W star back into either the labor supply or labor demand equation. I plug it here into the labor demand equation, but it doesn't make any difference. You're going to get the same answer. And then I substitute for W in that equation the value of W star, and I come up with 1,080,852 workers. So they're each making about $3,700 a month, and there's a little over 1 million of them working. But now 50,000 workers enter the state. So if 50,000 workers enter the state, how do we then change the labor supply equation? Labor demand, by the way, doesn't change. We know nothing that tells us labor demand has changed for this environment. We just know there's more workers, and more workers is supply. Well, literally, we simply add a number of workers to this. So if we had 150,000 plus 250 W, we're simply adding 50,000, such that we end up with a new labor supply equation of 200,000 plus 250 W. And then we have to think of what is now a new market clearing wage level and labor level for this. Well, a new market clearing would be using the new supply equation and equating it to the existing demand equation, and in which case we find that the wage falls to 3,617.02, and the number of workers that would be employed if everyone worked would be 1,104,255.6. Again, all we did was we increased the labor supply equation by the influx of workers, because I've said that we have 50,000 workers at any wage level. So if you think about this, you're going to end up with some kind of a graphic that ultimately is going to look like this. So we have labor supply, which appears to be coming through like this, and labor demand. And so if we have a 50,000 unit change at any wage level, so that means we're going to then see some labor supply, a new labor supply equation that's just shifted out parallel and to the right by 50,000 workers at any wage level. So we just know that it's going to be an increase of 50,000. Most of you that tackled this got this right, by the way. So then I asked you to provide this fully labeled labor market model, and you should have been able to do that. Here we have the labor demand equation and relation, where we know that if we set this up properly, given the equation, that it's going to have a terminal value here on the wage axis of 8,636.36, and on the X or labor axis of 1,900,000. We know that we've got labor supply, which will have a terminal value on the labor axis of 150,000, and it is sloping upwards. We then, for the new equation, have a terminal value of 200,000, and it's sloping upwards. And we could have gone ahead and identified, where these cross like this, but it's not necessary to do that. Some of you did. You did it fine. But I'm looking for these values, of course, and I'm then looking for the values begat by W star and L star, and then W1 and L1. So this is what you were looking for there. You should have given me all of these values. You should have labeled it properly. You should have been able to give me the right kinds of basic slopes. Remember that in this graphic, as in any of the others, I'm not looking for perfect proportional sloping. I'm not looking for perfect proportionality. I'm looking to make sure you understand what this generally should look like and how it should move.